Please take a moment to read the following disclaimers. Part 1 consists of defining EIFS, EIFS components, and EIFS with drainage components. By the end of this presentation, you will be able to define EIFS according to IBC and ASTM International, discuss the components of an exterior insulation and finish system, identify and summarize benefits including reuse and lightweight design, generalize results of the Department of Energy, testing of various types of exterior wall claddings including EIFS, comprehend how EIFS can help meet new code requirements for continuous insulation and air barriers, determine how EIFS and air barriers can save energy through a whole building energy modeling study performed by a third party. What are EIFS? EIFS is defined by ASTM and the IBC are non-structural, non-load bearing exterior wall cladding systems. Acceptable substrate, glass mat gypsum sheathing in compliance with ASTM C1177, exterior or exposure 1 wood-based sheathing, plywood or OSB, code compliant concrete masonry or Portland cement plaster, existing structurally sound uncoated brick or other wall masonry construction. Components of EIFS consist of an insulation board adhesively and/or mechanically fastened to the substrate. A fiberglass mesh is then embedded into a base coat, followed by a textured protective finish coat and optional primer. EIFS with drainage. A drainable system incorporates a water-resistant barrier between the insulation board and the substrate. The drainage point is most commonly achieved with vertical ribbons of adhesive applied over the back of the insulation board, shown in the illustration to the right. In addition to the previously listed components, the drainable system also incorporates, by design, other accessories and a means for evacuation of incidental moisture from behind the insulation board. Components of EIFS with drainage: an air and water resistant barrier, an insulation board adhesively and/or mechanically fastened to the substrate, fiberglass mesh embedded in a base coat, once again followed by a textured protective finish coat and optional primer. EIFS and EIFS with drainage. Both methods are engineered to provide a durable, energy efficient, design flexible, cost-effective exterior cladding for virtually all building types. Ultimately, the system used is determined by the architect in accordance with code and project requirements. Part 2 will cover the features and benefits of EIFS. EIFS is a cladding system that places insulation on the outside, a thermal blanket for your building that results into a highly efficient thermal envelope that helps maximize the efficiency of the heating and air conditioning system in use. EIFS is the perfect balance of form and function. It extends building lifespan through 99.6% drainage efficiency. It lowers structural weight. Up to 64% lighter steel studs can be used than with brick veneer. EIFS minimizes thermal bridging. It enhances curb appeal with virtually limitless design possibilities. The use of EIFS cuts energy use with 99% thermal efficiency and a maximum R value of 43.2. It protects framing, substrates, and cladding with advanced moisture protection and drainage. EIFS offers a wide variety of design flexibility and is suitable for all climates and virtually any type of building. This includes commercial or residential. EIFS can achieve almost unlimited economical aesthetics. Shape provided by the insulation board, which is easier to mold than heavier, denser materials, offers a freedom of design well beyond other cladding. Curves, arches, reveals, accent bands, sculptured details, and coins are all easily obtainable options. Given the versatility of the insulation in EIFS, architectural features such as shapes, logos, and life forms can become integral aspects of a building's design. Available in almost any color and a variety of textures, EIFS has the ability to blend into a well-established community or make a bold architectural statement. EIFS is no longer limited to the appearance of traditional stucco. Specialty finishes including granite, limestone, H-plaster, brick, and metal are all achievable. The pictures below depict EIFS simulating the appearance of brick, yet weighs 15 to 20 times less than most typical brick wall assemblies, putting much less stress on the structure. As shown below, EIFS can replicate almost any brick pattern and color. EIFS provides a much more cost-effective option to granite, reduces weight on the structure, and eliminates the need of a track or pin system to hold the stone panels in place. Limestone is another expensive and heavy material that can be more economically replicated by EIFS, thus eliminating the need for costly structural design. EIFS can be panelized, fabricated in a factory-controlled environment, speeding up construction, and eliminating lost days due to weather. EIFS is an excellent option for restoration and not limited to new construction. According to the U.S. Department of Energy, there are over 80 million buildings in the United States that were built prior to 1980. Many of these have little to no effective insulation. Of these buildings, 75% are expected to still be in use in 2050 and are likely to need exterior renovations as well as improved energy efficiency. EIFS can do both cost effectively without disturbing the interior space of the building. EIFS is a cost-effective option to overclad existing brick, block, or stucco facades, resulting in elimination of moisture intrusion, increased energy efficiency, and a fresh aesthetic appeal. The above picture is EIFS with drainage installed on an existing building at Dover Air Force Base. The air barrier and the 2-inch insulation helped eliminate moisture intrusion and added an R value of 7.5. Dover Air Force Base prior to restoration and after overcladding with EIFS with drainage. EIFS performance and third-party research. Department of Energy testing. In 2003, the U.S. Department of Energy, known as DOE, contacted EMA and proposed a thorough hygrothermal evaluation of EIFS alongside a number of other commonly used claddings. EMA accepted the offer and worked with the Oak Ridge National Laboratory, a Department of Energy facility also known as the ORNL. The idea was to design and construct a specific facility dedicated to this purpose. Testing was performed in 2 phases from January 2005 to May 2006 and June 2006 through June 2007. Phase 1 of the DOE testing consisted of EIFS panels on the southeast facade. Built in Hollywood, South Carolina, the National Exposure Test facility is a fully conditioned enclosure that is designed to accept completely instrumented wall sections. Phase 1 of the DOE EMA study lasted 17 months, evaluated 15 individual wall sections, which included barrier EIFS, EIFS with drainage, stucco, brick, and siding. All were positioned on the southeast elevation of the facility, and temperature, heat flux, relative humidity, and moisture contact data was collected 24 hours a day, 7 days a week. The data was transmitted to, monitored, and analyzed by the Oak Ridge National Laboratory. The picture below shows the EIFS panels next to the stucco, brick, and siding. Phase 2, the southeast face, lasted 13 months. Additional wall sections of all cladding were placed on the northwest side of the building, flaws added to their construction. These flaws allowed water to enter the wall behind the cladding in order to test more rigorously the water-resistant barrier components. This data was also monitored and analyzed by the Oak Ridge National Laboratory. Department of Energy testing results. The graphs below show the relative humidity on the underside of the water-resistive barrier. Sustained values in excess of 80% have the potential for mold growth. Panel 2 is a properly applied EIFS with drainage, and Panel 3 is an identical panel with a flaw, which allowed water to penetrate the wall behind the insulation component. As you can see, neither system ever sustained 80% humidity, and both systems performed as expected. Comparing the EIFS results with brick, which had felt paper acting as the water-resistant barrier behind the cladding. Here again, one panel, number 15, is perfect, and the other, number 14, is flawed. In the case of these panels, both at times retain moisture levels significantly higher than the EIFS. Department of Energy test conclusions. EIFS with a fluid-applied water-resistant barrier performed better than the other cladding. EIFS drained best and had lower relative humidity values through the wall components. EIFS with 4 inches of insulation outside the fluid-applied barrier and an empty stud cavity performed best. A link has been provided below so that you can see the reports yourself. Part 4, EIFS and energy efficiency. Model building codes are changing to require more insulation. Continuous insulation, also known as CI, is one way to achieve current energy codes. How does EIFS effectively fall into this category? Energy reduction in buildings will be the most important initiative the U.S. can focus on to truly reduce its energy consumption. Energy use in buildings across the USA. 48% of total U.S. energy is used by buildings. 70% of total U.S. electricity is used by buildings. 40% of total greenhouse gases are emitted by buildings. ASHRAE divides the U.S. into 8 principal climate zones as shown here. These are the basis upon which the IECC has established prescriptive guidelines for minimum effective R values for wall assembly design. This helps the architect to easily determine building insulation requirements as defined by the location of the project. 2018 IECC CIR value requirements for frame walls and mass walls. This table corresponds with the previous climate zone map indicating insulation requirements for climate zones. EIFS with 2 inches of EPS will meet all existing building codes. It can be installed with up to 12 inches of EPS, which meets any future building codes, further increasing energy efficiency. Adhesively attaching EIFS will not puncture the air barrier of the building. This means that the air barrier assembly can be tested and approved prior to the cladding system being attached. Much less risk compared to claddings that puncture the air barrier with ties and fasteners. It raises the question of how do you fix an air barrier after the cladding is installed. EIFS has over 30 years of proven performance in North America as a continuous insulation wall cladding. A whole building energy modeling study conducted by Medgar Morceau of Morrison Hirschfield shows how much energy can be saved by upgrading standard building code requirements with added insulation and an air barrier assembly in the wall. The baseline model was a 3-story office building, 54,000 square feet, 33% glazing. Testing was done in Dallas, Seattle, and Toronto. Testing conformed to A90.1-2007. During the test, all climates realized HVAC energy reduction. All climates realized total building energy reduction. Return on investment when using insulation thicker than baseline energy codes. Increasing insulation thickness from 2 inches to 4 inches shows an ROI of 25% in Toronto. Increasing insulation from 2 inches to 4 inches in Seattle resulted in an ROI of 11%. Increasing insulation from 1 inch to 2 inch in Dallas resulted in a return on investment of 20%. Return on investment and payback financial analysis were conducted to see if it makes sense to add an air barrier to a building. Energy savings and the added cost of installing an air barrier versus a weather-resistant barrier were used to make the return on investment and payback calculations. This analysis shows that adding an air barrier is the most cost-effective thing you can do to increase the energy efficiency of a building. In Toronto, the payback years was less than 14 months. Seattle was less than 2.5 years. And in Dallas was just over 4 years. In summary, EIFS are lightweight, durable, design flexible, attractive and appealing, cost-effective, and available in multiple textures, shapes, and colors. Various third-party sources have validated EIFS as a contributing value in energy conservation and reduced carbon footprint and sustainability. EIFS performance in ORNL tests are far superior to other cladding. EIFS is in the International Building Code and International Residential Code. Evaluation reports are available. EIFS provides the continuous insulation described in ASHRAE 90.1 and required by the International Energy Conservation Code. Can contribute to LEED certification in 5 categories. Extremely meaningful in energy and atmosphere category. Only cladding that has air barrier, insulation, and aesthetics in one engineered system installed by a single contractor with a single source warranty. Most importantly, EIFS has proven itself in the real world for 40 years in every climate on over 1 million projects. This concludes the AIA Continuing Education System program.